A very good morning to my dear students. Hope you all are well. Stay home, stay safe, stay motivated and start studying because it's high time we all should study. I, Harita Malani, working as an assistant professor in Electronics Communication Department of Manikela Alvarma Textile and Engineering College, Bhilwara. Today I am delivering my online lecture on subject fiber optic communication, and topic to be discussed is types of optical couplers. This is my fourth lecture. In the previous lectures I have discussed the basic introduction, variety of couplers, active and passive couplers, and the fiber, core and surface type of couplers. In continuation with that lecture, today I am starting with basic types of optical couplers. So there are 5 to 6 different couplers. So first we will discuss Y coupler. So Y coupler in the shape of alphabet Y. That means it is having one input and two output ports. The power is transmitted from input to output. Output side we are having two ports. So Y coupler is also called as tap coupler. This type of coupler simply divides a signal into two outputs. The power distribution ratio between two outputs can be precisely controlled, and it maintains the split ratio, the power distribution ratio, as 10 is to 90%, 20 is to 80, 30 is to 70, 40 is to 60% or 50 is to 50%. So this is Y coupler. Next is my T coupler in the alphabet T. So it is again having one input and two output terminals. So T couplers second figure shows that we can cascade to get multiple terminals on a T network. We can connect n number of T networks. If we are having we need more number of output terminals, then we can cascade this T coupler. So T couplers can be cascaded to connect multiple terminals on a network T. T couplers are readily available and can be terminated with standard connectors like SC, ST, FC, LC, etc. And you can quickly set up a small network with T couplers. So what does mean by SC? SC is a standard connector, ST is a straight tip connector, FC is a ferrule connector, and LC is a local connector. So we can connect these connectors on the basis of our application needed. Next, these are the images of all the different connectors. So FC, this is LC, and this is SC connector. Next is my star coupler. So by the name we get what is the significance of star coupler. It is having multiple inputs and multiple outputs. So this figure shows n number of input ports and m number of output ports. So what it does, star coupler have multiple inputs and outputs. The input and output port number could be the same or not. For example, we can have 2 cross 2, 2 cross 4, 4 cross 4, 8 cross 8, different types of star coupler. So role of star coupler distributes the input power uniformly among the output fiber. There are two types of star couplers, and this is a package of star coupler. If I want to purchase it from market, I have to tell the specific name, which type of star coupler I want, and how I will decide which star coupler is needed. It depends on the application which we are using it. Next is my types of coupler. First type is directional star coupler. The first type is directional. It mixes optical signals from all inputs and then distribute them among all outputs. So this is the first type. Mixing optical signals from all inputs and then distribute them among all outputs is shown in the previous figure. These are bidirectional devices because they also can transmit light in the opposite direction. So this is having two types, unidirectional and bidirectional star coupler. This directional type of star coupler is made by fusing multiple fibers together. In the next time I will show you how these are fused. So this is my directional coupler. Next is non-directional star coupler. So this is the second type. It takes input from fiber and then distribute them among all fibers, both input and output. Means a signal applied to any fiber appears at all other remaining fibers. Okay, in a non-directional type of star coupling device, a signal applied to any fiber appears at all other remaining fibers with the use of reflective mirrors. Such couplers can be used to work as a directional reflective star coupler. This type of coupler doesn't have large demand, but they are available in the market. See, this we are showing how fiber coupling is done. The first shows n number of fibers. Okay, coupling region is defined by twisting the optical fibers. Clear? So n number of inputs, n number of outputs. Second method by fusing or melting the fiber. Third is by fiber tapering. Next, I am showing you non-directional star coupler. See, this is the figure of star coupler. What do you mean by non-directional? Non-directional means he input a signal applied to any fiber. This is my port number 1, input port number 1. The signal is applied to this port. It will be uniformly distributed at all other ports, including input as well as output. So this is my non-directional star coupler. There are so many advantages because if I want to have n number of input and output terminals, then I can't use cascaded T coupler network because it will produce so much of loss, because each T coupler will add some noise, some losses to the final designing. So instead of T coupler, cascaded T coupler, I will use star coupler. This is because star coupler requires only one input connector and suppose only one excess loss. The larger number of terminals, the more significant are the loss benefits. So this is the advantage of star coupler. Clear? Any doubt? Next I will discuss tree coupler. Tree, by the name tree. See, it's very easy. Tree having input, trunk, supplying output to all the branches. So here I am having tree coupler. This is the diagram having one input port and m number of output ports. Opposite is also possible. This is 1 cross n tree coupler and this is n cross 1 tree coupler. And in market it is available and you can see the image how it looks like. So this is my tree coupler. Its package name is also mentioned over here. So tree couplers are also called 1 cross n couplers because they take one or two inputs and split it into multiple outputs. Tree couplers distribute the input power uniformly among the output fibers. Some may combine multiple inputs to one or two outputs. So this second n cross 1 is also possible. So most common configurations are here. 1 cross 4, 1 cross 8 till 1 cross 32, and if two inputs are there, the combination is 2 cross 4, 2 cross 8, 2 cross 32 port ratios. Tree couplers have been extensively used to split and mix optical signals and LANs and all other kinds of optical communication system. So next coupler is my WDM coupler, wavelength division multiplexing coupler. So WDM couplers, what it does, it selects wavelength. Okay, all other couplers are not depending on wavelength. They are wavelength independent. This is wavelength dependent coupler. So WDM couplers separate optical signals according to their wavelengths. They look like 1 cross 2 T coupler, but they do not just split the power blindly, but rather split two different wavelengths into two outputs. And the wavelengths are mentioned as 1310 oblique 1550 nanometers, or the second combination is 980 oblique 1550 nanometer couplers. So WDM couplers are used to separate wavelengths transmitted for different purposes through the same fibers, such as separating the light pumping an optical amplifier from the amplified signal. They should block wavelengths from entering the wrong output port. So today I will wind up my class with these different types of coupler. In next class, we will discuss coupled mode analysis of directional coupler. That is again a very lengthy topic and very important. So please students, my request that prepare a copy, write down this important headings at least and draw a few diagrams in your copy. And I hope you will enjoy this lecture and please study thoroughly. Thank you.